Let's do a quick overview of encryption here. So you'll have probably heard of this, have some experience, have some kind of connection to it, but let's look at what we mean by this and really answer this question: is it possible to send private messages using networks? So encryption is all about hiding or obscuring information in ways that it can be, we'll say, decoded. So it'd be really easy to hide or obscure information by just, randomly changing the numbers, randomly changing it, just completely jumbling it up. But the problem with that is that no one can read it. You can't even read it back. So encryption is all about producing something that to everyone else looks like a random jumble, but to the person who knows how to decode it, they can get it back. So examples of where you might want this is storing data that you're going to recover later, or sending messages, entering passwords. Yeah, so you can, I think it's pretty easy to imagine that anywhere that you don't want other people, other than the intended person, to read it, encryption is useful. So important terms to note: encrypt is making something secure. So this is the jumbling up step. Decrypting is making something, we'll say, clear again. This is the unjumbling. And then a key is a tool to allow encryption/decryption. So the thing that you use for encryption, or to encrypt something and to decrypt something, is a key. So here's the general idea of encryption. This is very kind of broad, but it'll help to track what's going on. Basically, we're going to transform data with a mathematical function. So if you remember, in computers, all of our data is just a collection of numbers. And so if we have a collection of numbers, we can do math on that and encrypt it. So some simple examples. This isn't how like modern cryptography would work, but it's a basic idea. So you could come up with an add to key. So if your secret number was 13758, and this means something. So add 2 would just be to add 2 to all of these. And then assuming that this top one meant something, the bottom one probably doesn't mean it. If you want to think about it kind of in terms of letters, you might have something like, if you had the word cat, add 2 would be go 2 letters later, so you'd have something like E, B, C, and then T, U, V. So obviously ECV is not something of meaning, but cat is. Now this is a fairly simple thing. It'd be easy to break it because someone could just look through and see, is there a basic shift that would make it make sense? But you can also do something, more complicated, like multiply, or use exponents, or use some combination. And this is what we end up having happen later. And we'll talk about it in the next video, some of the specifics of what kinds of encryption you can do. But this is the basic idea: is we do some sort of math on our data, and that changes it to data that is garbled and meaningless. When we're thinking about encryption, there's 2 broad categories that we're going to look at: symmetric key encryption and asymmetric key encryption. So symmetric key encryption is where both parties have the same key. So in the example of if you imagine kind of physically having a box that you lock, symmetric key encryption would mean you give your friend the same, like a copy of your key, and then you can pass the box around and both of you can open it. Asymmetric key, also known as RSA or public-private key encryption, is that you have basically a padlock that's publicly available. And this is known as the public key. And then you've got a key, like a physical key in this example, and that's private, and that's known as the private key. So there's a fancy math that goes along here, but the idea is you give people information that will let them lock or encrypt their data, but then you're the only one who can decrypt it. Even somebody who has that public key, that public padlock, the fancy thing about RSA or asymmetric key encryption is even though they know the data they put in, they know the public key, that padlock, they can't use that to find the private key. And this is what's so powerful and interesting about encryption in kind of modern computing, is we figured out this really well so that there are ways to quite literally make it so that only the person who knows the private key can find the answer in any reasonable amount of time.